To graph a slightly more complicated version of a logarithmic function, we're going to graph it in steps. I'm first of all going to graph the function y equals log of x. Since there's no base indicated, we can assume the base is 10. I don't want to get into the idea of plotting points or anything, so I'm just going to remember that the basic logarithm function looks like this. The asymptote is along the negative y-axis. The x-intercept occurs at 1. The log of 1 is 0, regardless what the base is. The next step is to look at the equation y equals the log of x plus 1. The effect of adding the 1 is to shift the graph, and sometimes we have a hard time realizing which way to shift it, but let's realize that the domain of this function says that the value of x has to be greater than minus 1. The input, x plus 1, has to be positive. So that tells me that everything takes place to the right of x equal negative 1. So if I take this graph and shift it 1 unit, we get this graph. The asymptote is now along the line y equal negative 1. The intercept is at the origin. Well, the next step is to see what happens with the 1/2 and then with the negative 1/2. Well, what the 1/2 does is takes each one of these y values and multiplies it by 1/2. So the new graph is only half as high. So I'll draw it in dotted. So it's only half as high, has the same intercept, dotted here, and the same asymptote. So it has roughly the same shape. The only thing is it's not quite as high as this graph. Now, the effect of the negative 1 is to flip this dotted graph over the axis. So I'm going to put the asymptote in at negative 1, x equal negative 1. The origin is still one of the points on the graph, and the new graph is this dotted graph flipped over. So it's going to look like this. The intercept is along the line x equal minus 1, or the asymptote. The intercept is at the origin, and that's what this graph has looked like. The domain we are asked for is x has got to be greater than negative 1. The range is the y values are any real number. The y values could be anything.